Alkaline earth metals. The elements in Group 2 of the periodic table are called alkaline earth metals. They consist of beryllium, magnesium, calcium, strontium, barium, radium. The electron arrangement of the first three alkaline earth metals is as indicated. An atom of an alkaline earth metal has 2 electrons in the outermost energy level. The atomic radius increases down the group as more energy levels are occupied. Beryllium has the smallest atomic radius among the alkaline earth metals because it has the least number of occupied energy levels. Group 2 elements form ions by losing the 2 electrons in the outermost energy level in order to attain a stable electron arrangement. The loss of 2 electrons in the outermost energy level accounts for the smaller ionic radius compared to the atomic radius of the corresponding atom. Beryllium ion with only 1 occupied energy level is therefore the smallest ion. Physical properties of the alkaline earth metals. To learn the physical properties of alkaline earth metals, let us observe this experiment. A piece of magnesium ribbon is cut and polished with sandpaper. The ribbon is then used to complete the electric circuit as shown. The procedure is repeated with calcium instead of magnesium. When an alkaline earth metal is polished, it acquires a metallic luster. Alkaline earth metals lose their metallic luster when exposed to air because of oxidation. The purpose of polishing the surface of the alkaline earth metals before using them in experiments is to remove the thin oxide layer that usually forms on their surface. Both magnesium and calcium have a metallic luster. Magnesium is hard to cut with a knife. However, it is ductile and malleable. Calcium is brittle, hence it cannot be cut with a knife. Both magnesium and calcium are good conductors of heat and electricity due to the presence of delocalized electrons. A ductile material is one which can be drawn into a wire. Materials which can be hammered into sheets are said to be malleable. A brittle substance is one which is hard and likely to break. The table summarizes some physical properties of alkaline earth metals. The melting and boiling points of beryllium are very high compared to other alkaline earth metals. This is because the beryllium atom is very small and the forces of attraction between the atoms are very strong. Down the group, the melting point and boiling points decrease. In metals, atoms are held together by forces of attraction between positive nuclei and delocalized electrons. As the atomic radius increases, this attraction decreases because of the increasing distance from the positive nucleus to the delocalized electrons. This explains why the melting point and boiling point decrease down the group. The melting and boiling points of alkaline earth metals are higher than those of alkali metals in the same period. This is because the forces holding the atoms in alkaline earth metals are stronger. The first ionization energy for magnesium is the minimum amount of energy required to remove one electron from the outermost energy level. The second ionization energy of magnesium is the minimum amount of energy required to remove a second electron from a magnesium ion with a single positive charge. The second ionization energy is always higher than the first ionization energy. Once an electron has been lost from an atom, the overall positive charge holds the remaining electrons more firmly. This then means that removing a second electron from the ion requires more energy than the first electron. Chemical properties of alkaline earth metals. To understand the chemical properties of alkaline earth metals, we will observe their reaction with air and water. Magnesium burns in air with a blinding brilliant white flame, forming a white solid. The white solid is a mixture of magnesium oxide and magnesium nitride. Calcium, on the other hand, burns with a faint orange-red flame, forming a white solid, which is a mixture of calcium oxide and calcium nitride. The trend in reactivity of the alkaline earth metals when burning in air is not clear due to the oxide coating on calcium. Magnesium reacts slowly with cold water to form magnesium hydroxide and hydrogen gas bubbles, which stick on the surface of the metal. Magnesium hydroxide dissolves slightly in water to form an alkaline solution. A steady stream of hydrogen gas is evolved when calcium reacts with cold water. A white precipitate appears in the beaker due to the formation of calcium hydroxide, which is sparingly soluble in water. The calcium hydroxide solution formed is alkaline. Similarity of ions and formulae of some compounds of alkaline earth metals. Both magnesium and calcium ions have a valency of 2. The hydroxide ion and chloride ion have a valency of 1. Therefore, 2 hydroxide ions combine with 1 magnesium ion to form magnesium hydroxide. Similarly, 2 chloride ions will combine with 1 magnesium ion to form magnesium chloride. On the other hand, the oxide ion has a valency of 2. Therefore, 1 calcium ion combines with 1 oxide ion to form calcium oxide. 1 magnesium ion combines with 1 oxide ion to form magnesium oxide. All alkaline earth metals have a valency of 2. Hence the chemical formulae of their compounds are similar. Thank you for watching this chemistry lesson. Please subscribe to this channel and other Genius channels relevant to your level of study.